Jakarta Persistence Architecture. This is the architectural diagram of Jakarta Persistence. Jakarta Persistence, JPA, formerly Java Persistent API, is a Jakarta EE application programming interface specification that describes the management of relational data in enterprise Java applications. Now we are focusing on jakarta.persistence. Jakarta Persistence is the API for the management for persistence and object relational mapping. As an example, we can consider jakarta.persistent package. Jakarta Persistence is the API for the management for persistent and object relational mapping. This is in module jakarta.persistent. As an exception example, we can consider class persistence exception thrown by the persistent provider when a problem occurs. All instances of persistence exception except for instances of no result exception, non-unique result exception, lock timeout exception, and query timeout exception will cause the current transaction if one is active and the persistence context has been joined to it to be marked for rollback. This is in module jakarta.persistence in package jakarta.persistence. As an error example, we can consider this. This occurred in the environment with Spring Boot, JPA, and Olingo. An attempt was made to call a method that does not exist. The attempt was made from the following location: org.hibernate.cfg.annotation binder.bind join table association. The following method did not exist: java x.persistent.join table.indexes, etc. An action: correct the class path of your application so that it contains a single comparable version of java.persistent.join table. Now we are focusing on EntityManagerFactory. The jakarta.persistence.EntityManagerFactory class is a factory for entity managers. The EntityManagerFactory interface is used by the application to obtain an application manage entity manager. When the application has finished using the EntityManagerFactory and or at application shutdown, the application should close the EntityManagerFactory. Once an EntityManagerFactory has been closed, all its entity managers are considered to be in the closed state. As an example, we can consider interface EntityManagerFactory. Interface used to interact with the EntityManagerFactory for the persistence unit. When the application has finished using the EntityManagerFactory and or at application shutdown, the application should close the EntityManagerFactory. Once an EntityManagerFactory has been closed, all its entity managers are considered to be in the closed state. This is in the module jakarta.persistence and in the package jakarta.persistence. As an example 2, we can consider this code segment. The following example illustrate the creation of EntityManagerFactory in Java SE environment and its use in creating and using resource local entity manager. Here the persistent class is a bootstrap class that is used to obtain an EntityManagerFactory in Java SE environment. It may also be used to cause schema generation to occur. Here you can see the create entity manager factory method with this method creates and return an entity manager factory for the named persistent unit. Here the parameter persistent unit name, the name of the persistence unit. Here you can see the entity manager factory interface used to interact with the entity manager factory for the persistent unit here. Here you can see create entity manager method, create a new application manage entity manager. This method returns a new entity manager instance each time it is invoked. The isOpen method will return true on the returned instance. Here you can see the close method. Close the factory, releasing any resources that it holds. After a factory instance has been closed, all methods invoke on it will throw the illegal state exception except for isOpen, which will return false. Once an entity manager factory has been closed, all its entity managers are considered to be in the closed state. As an example, we can consider illegal state exception. If the entity manager factory has been closed, in method entity manager create entity manager in interface entity manager factory. As an error example, we can consider this error occurred in the environment with Spring Data 2.6.1 with Eclipse link and Jakarta 3. Java.land.no class def found error. Java X persistence entity manager factory at org.spring framework.data.jpa.util bean definition utils, etc. Now we are focusing on entity manager. The jakarta.persistence.EntityManager is the primary JPA interface used by applications. An entity manager instance is associated with the persistence context. A persistent context is a set of entity instances in which, for any persistent entity, identify there is a unique entity interface, entity instance. Within the persistence context, the entity instances and their lifecycle are managed. The entity manager interface defines the methods that are used to interact with the persistence context. The Entity Manager API is used to create and remove persistent entity instances, to find persistent entities by primary key, and to query over persistent entities. As an example, we can consider interface Entity Manager. Interface used to interact with the persistence context. An Entity Manager instance is associated with a persistent context. A persistent context is a set of entity instances in which, for any persistent entity identified, there is a unique entity instance. Within the persistence context, the entity instances and their lifecycle are managed. The Entity Manager API is used to create and remove persistent entity instances, to find entities by their primary key, and to query over entities. The set of entities that can be managed by a given Entity Manager instance is defined by a persistent unit. A persistence unit defines the set of all classes that are related to or grouped by the application, and which must be located in their mapping to a single database. This is in module jakarta.persistence and package jakarta.persistence. As an example, we can consider this code segment. This is an example of use of Entity Manager API. Here, annotation type persistence context expresses a dependency on a container managed Entity Manager and its associated persistence context. Here you can see Entity Manager interface used to interact with the persistence context. Here you can see the find method, find by the primary key, search for an entity of the specified class, and primary key. If the entity instance is contained in a persistent context, it is returned from there. And this is entity class, the parameter, and this is primary key. Here you can see a persist method, make an instance managed and persistent. Here you can see the parameter entity instance here. As an example, we can consider entity exist exception. If the entity already exists, the entity exist exception may be thrown when the persistent operation is invoked, or the entity exit exception or another persistence exception may be thrown at flush or commit time in method void persist object entity in interface Entity Manager. As an error example, we can consider this no persistence provider for Entity Manager named error when trying to create EntityManagerFactory in an environment with Eclipse Dynamic Web Project and MariaDB using Hibernate ORM. No persistent provider for Entity Manager name persist unit. jakarta.persistence.create EntityManagerFactory etc. Now we are focusing on entity transaction. Each entity manager has one-to-one relation with a single jakarta.persistence.entity transaction. The entity transaction interface is used to control resource transaction on resource local entity managers. The EntityManager.getTransaction method returns an instance of the entity transaction interface. As an example, we can consider interface entity transaction. Interface used to control a transaction on resource local entity managers. The EntityManager.getTransaction method returns the entity transaction interface. This is in module jakarta.persistence and package jakarta.persistence. As an example too, we can consider this code segment. The following example illustrate the creation of an entity manager factory in a Java SE environment, and it's used in creating and using resource local entity manager. We are considering this here entity transactions. Here you can see the get transaction method returns the resource level entity transaction object. The entity transaction instance may be used serially to begin and commit multiple transactions. Here you can see a begin method in interface entity transaction. This starts a resource transaction. Here you can see a commit method. Commit the current resource transaction, writing any unflushed changes to the database. As an exception example, we can consider this one, illegal state exception. If isActive method is true in method void begin in interface entity transaction. Now we are focusing on query. The jakarta.persistence.query interface is implemented by each vendor to find persistent objects that meet certain criteria. Jakarta persistence query language, criteria API, and native SQL select queries are executed using the get result list and get single result methods. Update and delete operations, update and delete queries are executed using the execute update method. As an example, we can consider interface query. Interface used to control query execution. This is in module jakarta.persistence and package jakarta.persistence. As an example too, we can consider this code segment here with EntityManager. You can see here the create query method. And here the Jakarta persistent query string. The create query method here creates an instance of query for executing a Jakarta persistent query language statement. Here you can see the set parameter method in query, bind an argument value to a named parameter. Here bind an argument value to a name parameter here. This is the parameter name and this is the parameter value. Here you can see a set max result method in query interface. Set the maximum number of results to retrieve, here 10. Here you can see a get result list in query interface. Execute a select query and return the query results as an untyped list. For type query instances, the query result type is determined in the case of criteria queries by the type of query specified when the criteria query is created. In the case of Jakarta persistence query language queries, the type of the result is determined by the result class argument to the create query or create named query method, and select list of query must contain only a single item which must be assignable to the specified type. Here you can see typed query interface used to control the execution of typed queries. Here you can see EntityManager's the create query method in EntityManager here with the parameter. This is the criteria query parameter, a criteria query object here, and this create query method creates an instance of typed query for executing a criteria query. Here you can see a get single result method of type query. Execute a select query that returns a single result. And the type query is in module jakarta.persistence and package jakarta.persistence. As an example 4, we can consider this one. This example illustrates the case where a native SQL query is created dynamically using the create native query method, and the entity class that specify the type of the result is passed as an argument. When executed, this query will return a collection of all the entities for items name widget. Here you can see the method create native query in EntityManager. Create an instance of query for executing a native SQL query. Here you can see a native SQL query string, and this is the class of the resulting instances. As an example 5, we can consider this. Here you can see the method create stored procedure query method in EntityManager. Here create an instance of stored procedure query for executing stored procedure in the database. Here you can see the procedure name, and the interface stored procedure query interface used to control procedure query execution, control stored procedure query execution. And design jakarta.persistent module and jakarta.persistent package. As an exception example, we can consider illegal state exception. If called for a Jakarta persistent query language, update or delete statement in method list get result list in interface query. Now we are focusing on persistence. The jakarta.persistence class contains statics helper methods to obtain EntityManagerFactory instances in a vendor neutral fashion. Within a container, you will typically use injection to access an EntityManagerFactory. Applications operating outside of a container, however, can use the persistent class to obtain EntityManagerFactory objects in a vendor neutral fashion. As an example, we can consider class persistence, bootstrap class that is used to obtain an EntityManagerFactory in Java SE environments. It may also be used to cause schema generation to occur. This is in module jakarta.persistence and in package jakarta.persistence. Here you can see the as an example 2, we can consider this the content of example file persistent.xml. A persistence.xml file defines a persistent unit. The persistence.xml is located in meta-inf directory of the root of the persistence unit. It may be used to specify manage persistence classes included in the persistence unit. It may be used to specify manage persistence classes included in the persistence unit, object relational mapping information for those classes, and scripts for use in schema generation and bulk loading of data and other configuration information for the persistence unit and for the entity managers and EntityManagerFactory for the persistence unit. This information may be defined by containment or by reference. Here you can, as an example 3, you can see obtaining an entity manager factory in a Java SE environment. Outside a Jakarta EE container environment, the jakarta.persistence class is the bootstrap class that provides access to an entity manager factory. The application creates an entity manager factory by calling the create entity manager factory method of the Jakarta persistence jakarta.persistence class. The method entity manager factory the method create entity manager factory string persistence unit name here creates and returns an entity manager factory for the named persistence unit. As an exception example, we can consider persistence exception. If insufficient or inconsistent configuration information is provided, or if schema generation otherwise fails, in method generate schema string persistence unit name map in class persistence. Now we are focusing on entity. Entities are persistent objects that represent data store records. An entity is a lightweight persistent domain object. Here you can see the life cycle of an entity with respect to the APIs. Here you can see the entity manage operations for managing an entity instances life cycle. An entity instance can be characterized as being new, managed, detached, and removed or removed. New entity instance has no persist identity and is not yet associated with the persistence context. A managed entity instance is an instance with a persistent identity that is currently associated with the persistence context. Detached entity instance is an instance with a persistent identity that is not or no longer associated with the persistent context. A removed entity instance is an instance with a persistent identity associated with the persistence context that will be removed from the database upon transaction commit. Here the use of the cascade annotation element may be used to propagate the effect of an operation to associated entities. The cascade functionality is most typically used in parent-child relationships. Entity instances are created by means of the new operation. An entity instance, when first created by new, is not yet persistent. An instance becomes persistent by means of the EntityManager API. Persisting an entity instance, a new entity instance become both managed and persistent by invoking the persist method on it, or by cascading the persist operation. Semantics of the persist operation applied to an entity X are as follows. If X is a new entity, it becomes managed. The entity X will be entered into the database at or before transaction commit, or as a result of flush operation. If X is a pre-existing managed entity, it is ignored by the persist operation. However, the persist operation is cascaded to entities referenced by X if the relationships from X to these other entities are annotated with the cascade equal persist or cascade equal all annotation element value, or specified with the equivalent XML descriptor element. If X is a removed entity, it becomes managed. If X is a detached object, the entity exception may be thrown when the persistent operation is invoked, or entity exception or another persistent exception may be thrown at flush or commit time. For all other Y referenced by a relationship from X, if the relationships to Y has been annotated with the cascade element value, cascade equals persist or cascade equal all, the persist operation is applied to Y. Removal. A managed entity instance becomes removed by invoking remove method on it, or by cascading the remove operation. The semantics of the remove operation applied to an entity X are as follows. If X is a new entity, it is ignored by the remove operation. However, the remove operation is cascaded to entities referenced by X if the relationship from X to other to these other entities are annotated with the cascade equals remove or cascade equals all annotation element value. If X is a managed entity, the remove operation causes it to become removed. The remove operation is cascaded to entities referenced by X if the relationships from X to these other entities are annotated with cascade equal remove or cascade equal all annotation element value. If X is a detached entity, an illegal argument operation illegal argument exception will be thrown by the remove operation, or the transaction commit will fail. If X is a removed entity, it is ignored by the remove operation. A removed entity X will be removed from the database at or before transaction commit. Or as a result of flush operation. After an entity has been removed, its state, except for generated state, will be that of the entity at the point at which the remove operation was called. Detached entities. Detached entity results from transaction commit if a transaction scope persistence context is used from transaction rollback. From detaching the entity from persistent context, from clearing the persistent context, from closing an entity manager, or from serializing an entity or otherwise passing an entity by value to a separate application tier through a remote interface, etc. Detached entity instances continue to live outside of the persistence context in which they were persisted or retrieved. Their state is no longer guaranteed to be synchronized with the database state. The application may access the available state of available detached entity instances after the persistence context ends. The available states the available states includes any persistent field or property not marked lazy, fetch equals lazy, any persistent field or property that was accessed by the application or fetch by means of an entity graph. If the persistent field or property is an association, the available state of an associated instance may only be safely accessed if the associated instance is available. The available instances include any entity instance retrieved by using find method, any entity instances retrieved by using a query or explicitly requested by in a fetch join, any entity instance for which an instance variable holding non-primary key persistent state was accessed by the application, any instance that can be reached from another variable instance by navigating associations marked fetch equal eager. Here you can see new transient. New transient is new transient interacts with managed. Persist is passed from new transient to manage, and rollback new is passed from manage to new transient. Rollback is an extended persistence context. Manage interacts with new transient, and removed and detached. Refresh is passed from managed to managed. Remove is passed from managed to removed. Persist, rollback passed from removed to managed. Rollback here is an extended persistence context. Commit, rollback close are passed from managed to detached, and merge is passed from detached to managed. Here detached interact with managed, and removed interacts with managed. Remove is connected to new transient. Commit is passed from remove to new transient. Remove is connected to detached. Rollback is passed from remove to detached. Here you can see entity and relational database table relation. An entity is a persistent domain object. Each entity represents a table in a relational database, and each entity instance corresponds to a row in a in that table. Jakarta persistence uses annotations of XML to map entities to a relational database. The persistent state of an entity field, so properties, setter and getter methods use object relational mapping annotations to map the entities and entity relationships to the data, the relational data in the underlying data store. Here you can see each entity represent a table in a relational database, and each entity instance represent a table row in a relational database. As an example, we can consider annotation type entity. Specified that the class is an entity. This annotation is applied to the entity class. This is in module jakarta.persistence and package jakarta.persistence. As an example 2, we can consider this code segment, creating an employee entity. Here the annotation type ID specifies the primary key of an entity. The field or property to which the ID annotation is applied should be one of the following types: any Java primitive type, any primitive wrapper type, string java.util.date, java.sql.date, java.math.bigdecimal, java.math.biginteger. Here the annotation type generated value provides for the specification of generation strategies for the values of primary keys. As an example 3, we can consider this code segment. Mapping of derived identities. Here the dependent entity uses ID class to represent a composite key. The annotation type ID specifies the primary key of an entity. The field or property to which the ID annotation is applied should be one of the following types: any Java primitive type, any primitive wrapper type, string java.util.date, java.sql.date, java.math.bigdecimal, java.math.biginteger. The mapped column or for the primary key of the entity is assumed to be the primary key of the primary table. If no column annotation is specified, the primary key column name is assumed to be the name of the primary key property or field. So here the string name matches the name of the ID attribute. Long emp matches the name of the ID attribute and the type of the employee primary key. And here the ID attribute mapped by join column default. As an example 4, we can consider this code segment: bidirectional one-to-one relationships. Here the annotation type one-to-one specifies a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify the associated target entity explicitly, since it can usually be inferred from the type of the object being referred. If the relationship is bidirectional, the non-owning side must use the mapped by element of the one-to-one annotation to specify the relationship field or property of the owning side. Here, assuming that entity A here references a single instance of entity B, and entity B references a single instance of entity A. Entity A is specified as the owner of the relationship. The following mapping defaults apply. Entity A is mapped to a table named A, then entity B should map to a table named B. Table A contains a foreign key to table B. The foreign key column name is formed as the concatenation of the following: the name of the relationship property or field of entity A, underscore the name of the primary key column of the table B. The foreign key column has the same type as the primary key of the table B, and there is a unique key constraint on it. Here similarly, entity employee references a single instance of entity cubicle, and entity cubicle references a single instance of entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply here. The entity employee is mapped to a table named employee. Entity cubicle is mapped to a table named cubicle. Table employee contains a foreign key to table cubicle. The foreign key column is named assigned cubicle. Underscore primary key of cubicle, where primary key of cubicle denotes the name of the primary key column of the table cubicle. The foreign key column has the same type as the primary key of cubicle. There is a unique key constraint on it. As an example 5, we can consider bidirectional many-to-one and one-to-many relationships. The annotation type many-to-one specifies a single valued association to another entity class that has many-to-one multiplicity. It is not normally necessary to specify the target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, the non-knowing one-to-many entity side must use the mapped by element to specify the relationship field or property of the entity that is the owner of the relationship. Here annotation type one-to-many specified a many valued association with one-to-many multiplicity. Here entity employee references a single instance of entity department. The entity department references a collection of entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply. The entity employee is mapped to a table named employee. The entity department is mapped to a table named department. The table employee contains a foreign key to the table department. The foreign key column is named department underscore primary key of the department, where primary key of the where primary key of the department denotes the name of the primary key column of the table department. The foreign key column has the same type as the primary key department. As an example 6, we can consider unidirectional one-to-one relationships. The annotation type one-to-one specifies a single valued association to another entity that has one-to-one multiplicity. It is not normally necessary to specify associated target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, the non-owning side must use the mapped by element of the one-to-one annotation to specify the relationship field or property of the owning side. Here the entity employee references a single instance of entity travel profile. Entity travel profile does not reference entity employee. The entity employee is the owner of the relationship. The following mapping defaults apply here. The entity employee is mapped to a table named employee. The entity travel profile is mapped to a table named travel profile. The table employee contains a foreign key to table travel profile. The foreign key column is named profile underscore primary key of travel profile, where primary key of the travel profile denotes the name of the primary key column of the table travel profile. Foreign key column has the same type as the primary key of the travel profile, and there is a unique key constraint on it. As an example 7, we are considering unidirectional many-to-one relationships. The annotation type many-to-one specifies a single valued association to another entity class that has many-to-one multiplicity. It is not normally necessary to specify the target entity explicitly, since it can usually be inferred from the type of the object being referenced. If the relationship is bidirectional, the non-owning one-to-many entity side must use the mapped by element to specify the relationship field or property of the entity that is the owner of the relationship. Here the entity employee references a single instance of entity address. An entity address does not reference entity employee. Entity employee is the owner of the relationships. The following mapping defaults apply. The entity employee is mapped to a table named employee. Entity address is mapped to a table named address. The table employee contains a foreign key to table address. The foreign key column is the name of the address underscore primary key of address, where the primary key of address denotes the name of the primary key column of the table address. The foreign key column has the same type as the primary key of the address. As an example 8, we can consider this one, the bidirectional many-to-many relationships. The annotation type many-to-many specifies a many valued association with many-to-many multiplicity. Here the entity project references a collection of entity employees. The entity employee references a collection of entity project. The entity project is the owner of the relationship. The entity project is mapped to a table named project. These are the mapping defaults now. The entity employee is mapped to a table named employee. And there's a join table that is named project underscore employee owner name first. This join table has two foreign key columns. The one foreign key column refers to the table project and has the same type as the primary key of project. The name of this foreign key column is project primary key of project, where the primary key of project denotes the name of the primary key column of table underscore project. The other foreign key column refers to the table employee and has the same type as the primary key of employee. The name of this foreign key column is employees primary key of employee, where primary key of employee denotes the name of the primary key column of table underscore employee. As an example 9, we can consider this one, unidirectional one-to-many relationships. The annotation type one-to-many specifies many valued association with one-to-many multiplexity. The entity employee references a collection of entity annual review and entity annual review does not reference entity employee. Entity employees is the owner of the relationships. The following mapping defaults apply here. The entity employee is mapped to a table named employee. Entity annual review is mapped to a table named annual review. There's a join table that is named employee underscore annual review. The owner name first. This join table has two foreign key columns. One foreign key column refers to the table employee and has the same type as the primary key of employee. The foreign key column is named employee primary key of employee, where primary key of employee denotes the name of the primary key column table of underscore employee. The other foreign key column refers to the table annual review and has the same type as the primary key of annual review. This foreign key column is named annual reviews primary key of annual review, where primary key annual review denotes the name of the primary key column of table underscore annual review. There is a unique key constraint on the foreign key that refers to annual review. As an example 10, we can consider this one, this code segment, unidirectional many-to-many relationship. Here the annotation type many-to-many specified a many-valued association with many-to-many multiplexity. The entity employee here references a collection of patent. The entity patent does not reference entity employee. Entity employee is the owner of the owner of the relationship. The following mapping defaults apply here. Entity employee is mapped to a table named employee. Entity patent is mapped to a table name patent. There's a join table that is named employee underscore patent, owner name first. This join table has two foreign key columns. One foreign key column refers to the table employee and has the same type as the primary key of employee. The foreign key column is named employee primary key of employee, where primary key of employee denotes the name of the primary key column of the table underscore employee. The other foreign key column refers to the table patent and has the same type as the primary key of patent. This foreign key column is named patent's primary key of patent, where primary key of patent denotes the name of the primary key column of the table underscore patent. As an example 11, we can consider abstract class as an entity. The annotation type inheritance specifies the inheritance strategy to be used for an entity class hierarchy. It is specified on the entity class, that is the root of the entity class hierarchy. If the inheritance annotation is not specified or no inheritance type is specified for the entity class hierarchy, the single underscore table mapping strategy is used. Here an abstract class can be specified as an entity. An abstract entity differs from a concrete entity only in that it cannot be directly instantiated. An abstract entity is mapped as an entity and can be the target of queries which will operate over and or retrieve instances of its concrete subclasses. Here the annotation type entity specified that the class is an entity, and this annotation is applied to the entity class. Here annotation type table specifies the primary table for the annotated entity. The additional tables must be specified using secondary table or secondary tables annotation. Here the annotation type discriminator value specifies the value of the discriminator column for entities of the given type. Here the annotation type primary key join column specifies the primary key column that is used as a foreign key to join to another table. Here the inherit EMP ID, but the mapped in this class to ft underscore emp dot ft underscore emp id. Inherit version map to emp dot version, and inherit address map to emp dot address fk. Default to ft underscore emp dot salary here, and here the primary key column is pt underscore emp dot emp id due to primary key join column default. As an example 12, we can consider concrete class as a mapped superclass. The annotation type mapped superclass designate the class whose mapped information is applied to the entities that inherit from it. A mapped superclass has no separate table defined for it. Here the annotation type join column specifies the column for joining an entity association or element collection. If the join column annotation itself is defaulted, a single join column is assumed and the default values apply. Here the annotation type association override is used to override the mapping of for an entity relationship. Here name is required and the name of the relationship property whose mapping is being overridden if the property based access is being used, or the name of the relationship field if field based access is used. Here join columns, the join columns being mapped to the persistent attributes. Here the default table is here EMP FT employee, and here the inherited EMP ID field mapped to FT employee dot EMP ID. Here the inheritance version field mapped to FT employee dot version. Here the inheritance address field mapped to FT employee dot ADDR FK, and the defaults to FT employee dot salary. Here the inheritance inheritant EMP field mapped to PT underscore EMP dot EMP ID. Here inheritance field is mapped to PT underscore EMP dot version, and here address field is mapping address field mapping overridden to PT underscore EMP dot ADDR underscore ID FK. As an example 13, we can consider this code segment non-entity superclass. An entity can have non-entity superclass which may be either concrete or abstract class. And here operation count is in transient state. As an example 14, we can consider naming of database objects. Here the annotation type table specifies the primary table for the annotated entity. Additional tables may be specified using secondary table or secondary tables annotations. As an example, we can consider class entity not found exception thrown by the persistence provider when an entity reference obtained by EntityManager.get reference is accessed, but the entity does not exist. Thrown when EntityManager.refresh is called and the object no longer exists in the database. Thrown when EntityManager.lock is used with the pessimistic locking is used and the entity no longer exists in the database. Using the package jakarta.persistence and the module jakarta.persistence. This is end of my presentation, and thank you very much for watching it.